Welcome back to Aurora Tech Channel. Today, I will be reviewing the Sunlu T3, a budget 3D printer that claims to print at the speed of 250 millimeters per second. This is quite a bold claim for a printer in this price range, but let's see what features are available for just $200. The Sunlu T3 has a very similar design to the Ender 3 Neo, which is the latest model of the Ender 3. The print volume is 220 by 220 by 250. It's a bed slinger with a Bowden setup and a classic LCD screen. It comes with a 3D Touch auto beveling sensor and a smart filament runout sensor that has a roller inside to detect if the filament is continuously feeding or not, similar to the Bigtree Tech Smart sensor. Although it's a Bowden setup, the extruder is a Bondtech clone dual-gear metal extruder, and the hot end is a regular one. It looks like an MK8 with a slightly larger heat sink. The part cooling fan is a 4010 blower. There are belt tensioners on both the X and Y axis, and the print surface is a magnetic sticker sheet with a heat insulation heated bed. The power supply is a Meanwell 350 watt. Despite the pretty decent hardware of the Sunlu T3, considering its price, I do have doubts about its ability to achieve high-speed printing without certain critical upgrades, such as a stronger extruder, a high-flow hot end, a linear rod or rail motion system, and a Core XY kinematic or at least a box frame. Additionally, the input shaping feature from Clipper firmware is necessary too. I am curious to see how the printer will perform at the advertised speed with this basic hardware and Marlin firmware. I would like to thank Sunlu for sending me this machine to review, and with that, let's get started. We have the base with the Y-axis and the LCD screen, a gantry with the X-axis and the print head, a power supply, a filament holder, a roll of 200 grams of sample filament, cables, and some tools. Assembling the machine is easier than an Ender 3 as the gantry is pre-assembled, and you only need to use 4 screws to secure it to the base. Mount the power supply on the side, mount the filament holder on the top, flip the switch in the power supply to match your local voltage, and all cables are connected except for the one from the power supply to the motherboard. The assembly is now complete. First, let's set this printer up in Cura. I will use a standard Ender 3 profile in Cura since this printer is basically an Ender 3. I will use regular 50 millimeters per second speed to slice a cube to ensure that everything is working properly. The cube looks good, with only some minor cooling issues, which is normal since the printer only has a 4010 cooling fan like an Ender 3. The X and Y surfaces are similar, with minor cooling issues. The Z surface is a bit rough, but the overall dimensions are accurate. Next, we'll slice a 3D Benchy using normal speed as a baseline to determine the printer's best print quality. The Benchy took 1 hour and 47 minutes, which is similar to the Ender 3's 1 hour and 50 minutes print time. The quality is good, with no stringing and decent cooling. There is no ringing when printing at a normal speed of 50 millimeters per second. Since the printer has a fast print mode, I will use the LCD screen to turn on this mode to print the same G-code file and see what happens. However, you can see cooling issues in many areas, the surface is not clean, and the ringing is bad. It seems this fast print mode just increases the print speed without making any other adjustments, which is not ideal, since everything can't be printed at such high speeds. The print is fast, taking only 39 minutes, but the overall quality is very poor, especially the horrible chimney of the Benchy. To see if we can achieve a better quality while printing quickly, I will create a new print profile in Cura to print at 250 milliliters per second. I will set the travel and infill to 250, the walls to 125, and the first layer to 40. The acceleration will be set to 1,500 millimeters per second squared to match the firmware settings. For small features, I'll slow it down to 25%, which will print at around 60 millimeters per second. As the fast print mode didn't give us our desired results, I will turn it off and just use the slicer to control the print speed. The Benchy takes 1 hour and 11 minutes. The quality is not perfect, but it is more presentable than the one printed with their fast print mode. The surface is not very clean, and there is some ringing, but it's not too bad and is acceptable for a fast prototype. Then, I will try printing a functional part with simple geometry, like a cable pass-through for the Ender 5 or Sovol SV05, using my 250 milliliters per second profile to print a fast one first. This took 5 hours and 34 minutes, and the result is decent, so the part is still usable. I will then slice it again using 50 millimeters per second in speed. Which took 11 hours and 31 minutes, which is 6 hours longer than the fast one, but the quality is better. However, for a functional part like this, saving 6 hours by printing the fast version is preferable. After that, I will attempt to print with ABS, which is faster than PLA since it doesn't require cooling. I will start with a speed of 50 millimeters per second, but the first attempt failed as the print didn't stick to the bed. After applying Elmer's Craft Bond Extra Strength glue, I tried again. The second attempt took 1 hour and 40 minutes, and despite some warping on one side, the rest of the print is fine. Considering the challenging conditions of printing in a 15°C garage without an enclosure, the print turned out quite well. I applied more glue and tried to reprint it using my 250 millimeters per second profile. The second print took 59 minutes, and the print stuck perfectly this time. While the print quality wasn't as good as the normal print speed, it was still usable and saved 40% of total print time. Next, I want to print a toy Jeep with the more complex geometry and detail. I'll start with a speed of 50 millimeters per second, which took 10 hours and 41 minutes to complete. The print quality was very good and on par with most other FDM printers that print at the same speed. I then tried my 250 millimeters per second profile. But the quality wasn't as good and the print under extrusion in the infill. The second print took 6 hours and 22 minutes, and while it wasn't terrible from the side, there are noticeable under extrusion, stringing, and layer imperfections at the bottom, front, and back. For this print, the 4-hour time saving isn't worth the decrease in quality, so I would rather spend the extra time and get a better result. Then, I will try printing with PETG and start with a set of cable rollers at a speed of 50 millimeters per second. The quality is excellent, with clean threads and smooth roller operation after some minor cleanup. I then attempted to print another set using the 250 millimeters per second profile, but the filament didn't stick well and there was some serious extrusion issues. Even after increasing the printing temperature from 225 to 240 degrees Celsius and eventually 245 degrees Celsius, the PETG couldn't be printed at such a high speed. Finally, I will try printing with TPU, which can be challenging with the Bowden setup. However, Area 1 TPU is easy to print, and even a stock Ender 3 can handle it. As expected, the 4 wheels were printed nicely, with no stringing and no imperfections, even though they were printed simultaneously. I used them to replace the wheels on the Jeep from before, and they look pretty good. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The hardware of this machine is not bad, and it is actually pretty good for $200. You get a 32-bit motherboard with silent stepper drivers on the X, Y, and Z axis, as well as the extruder. The filament holder on this printer is redesigned to extend a bit outside the frame, which can provide a better feeding angle. Additionally, the 2 bearings that are added to the filament sensor can also provide a smoother feeding experience for the filament as it moves through the extruder. The filament sensor works the same as the Big Tree Tech Smart Filament Sensor. A regular filament sensor is like a limit switch. When the filament is inserted, it presses the button inside and it thinks the filament is feeding normally, even if the filament is broken, and just leaves a piece inside the filament sensor. However, this smart sensor actually has rollers inside that keeps moving when the filament is feeding, so if the filament breaks, the rollers will stop rolling and will send the filament runout signal to pause the print, which works better but costs more than a regular filament sensor. The heated bed includes a heat insulation layer, which is not usually found on machines in this price range. The machine comes with an additional set of bed leveling knobs, which are designed to work together as a double lock mechanism. By holding the upper knob and tightening the lower knob, the 2 knobs can be locked together to ensure that the bed stays level during printing. This is a useful feature that can help improve print quality and reduce the need for frequent bed leveling. The extra cooling fan blowing at the extruder stepper motor is supposed to prevent the overheating of the motor during high-speed printing. However, it is unlikely that the stepper motor would become too hot during print speeds that produce reasonable print quality on this printer. 2. The print quality when printing at a normal 50 millimeters per second speed is really good. For fast printing, it works for some simple functional parts, but I will talk more about the print quality in the cons section. 3. The assembly is easy, as you don't have to put the X-axis together on your own. All cables, including all the stepper motors and limit switches, are also connected, so the only cable you need to connect is the one from the power supply to the motherboard. Now for the cons. Although the hardware is pretty decent for a $200 3D printer, none of it can support high-speed printing. The standard acceleration of an Ender 3 is 500 millimeters per second, and this Sunlu T3 only cranks up the acceleration to 1,500. You can actually do the same thing using the LCD screen of your Ender 3 or by editing the firmware. The fast printing mode just doesn't work. It only boosts the speed to around 200% and doesn't bother with what you are printing and won't even increase the nozzle temperature. You can also do the exact same thing by turning the knob on your Ender 3 LCD screen and boosting everything up to 200% and get a horrible result. Therefore, everyone should probably avoid using the fast print feature in the menu. If you do need to print faster, you can create a faster print profile in Cura that speeds up to 125 to 250 millimeters per second and sets the acceleration to 1,500 to match the firmware settings of this printer. This can print 50% to 100% faster with still acceptable results on simple geometric functional parts, but definitely not 5 times faster like a premium build Bamboo Lab X1 or Voron. 2. The 3D Touch bed leveling sensor on my unit was dead before I completed all the test prints. However, I replaced it with a $10 3D Touch and it is now working fine. I have installed several 3D touch sensors on different printers, and while they may not be as accurate as a genuine BL Touch, they tend to be durable. So, it is possible that receiving a defective 3D Touch is a rare occurrence. 3. The magnetic sticker sheet print surface is a bit outdated. It sticks okay, but it's not very durable. Although this is a budget printer, other budget printers like the Elegoo Neptune 3 come with a PI textured sheet for the same price. So, Sunlu can consider putting a PI textured sheet on their printer as well. Overall, other than the unrealistic fast printing claim and the defective 3D Touch, I have no other complaints. For just $200, the hardware of this printer is actually pretty decent. However, marketing it as a 250mm per second fast printing printer is not a good idea, as that's just not the case. It is possible that Sunlu could increase sales of this machine by marketing it as a $200 printer that offers upgraded features and better quality parts compared to other printers in its price range, all of which would make the machine more attractive to potential buyers. Finally, I would recommend that Sunlu releases a new firmware update based on Marlin 2.1.2 that supports input shaping. Since the printer does not come with an accelerometer or support for using one with Marlin, Sunlu could pre-calibrate the input shaping values using a factory stock machine and include them with the firmware release. Although this update may not work as efficiently as Clipper, which runs on a faster processor like the Raspberry Pi, it still has the potential to improve print speed and quality compared to the current firmware version. Anyway, if you are interested in this machine, I put a link under the description. Thank you for watching. If you found this review helpful, please give it a thumbs up, subscribe to our channel, and turn on notifications so you can stay updated on our latest videos. I will see you next time.